Hey guys, this is Eddie the Magic Monk. Welcome to another vectors lesson. Today I want to talk about a different kind of notation for specifying vectors. So far we have learned that if we have a vector, let's say it starts at the origin and it goes to a point on your Cartesian plane. So let's say this is the x coordinate of that point and this is the y coordinate of that point. So the way you would specify this vector, let's call it vector A, is vector A is equal to x times unit vector I plus y times unit vector j. Now, an easier way of specifying this vector is simply put it in angle brackets like this, x, y, like so. Now, this looks a little bit similar to the coordinates that you're used to with curly brackets. However, this is different when you put it in angle brackets, and here is why. Because if you put it in angle brackets, it means that you have a vector, which means that you can put this arrow anywhere. So you can copy this arrow and put it anywhere on your coordinate system. So you can put it over here, you can put it over there, you can put it over here. It is all represented by this notation. Whereas if you put it in curly brackets, then that represents a point, a single point, which is that point there. But if you put it inside angle brackets, that represents that this vector is going from its starting point, which is over here right now. Okay, it's going to move x units to the right. X units to the right horizontally, if I can draw that. And it's going to move y units up vertically. And it doesn't matter where you put the vector, you still use the same notation. So it's not this one, it's the one with the angle brackets. Okay, so let's see if you can do that. So I'm gonna draw a vector and see if you can specify the vector for me in both notations. Okay, so see if you can tell me what vector u equals in both notations and come back when you're done. Okay, so the first way is we have -3 along the x-axis plus 5 units along the j-axis, the y-axis. Or we could simply say -3, 5. Okay, so now that you are familiar with both kinds of notation, okay, we're going to teach you guys how to specify a vector joining 2 points on the Cartesian plane. So this is our Cartesian plane, and let me just give you any 2 points on this plane. So let's say we have point A is over here, and let's say this is -5 and -3 along the x and the y axis, and then let's have -1 and 1, 2, 3, 4, and then I call this vector point B. Okay, so now I want to know what the vector is joining from point A to point B. So point A has the coordinates -5, -3. Point B has the coordinates 4 and -1, and I want to know what the vector going from point A to B is. And these vectors have a notation like this, saying that we're starting at point A and we're going to point B, ending at point B. So try to see if you can figure it out for yourself. So it'll be something I plus something J. See if you can fill that in, or you can write it as in angle brackets, not curly brackets, angle brackets, something in these boxes. Okay, come back when you're done. Okay, so all you have to do is look at how many units has it moved along the x-axis. So you can simply count it if you like. So you can simply go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's moved 9 units along the x-axis. And how many units has it moved upwards? Well, you just go from here horizontally 1, 2. It's moved 2 units upwards. So you can simply do that, or if you want to do it mathematically, you can just get the coordinate for point B minus the coordinate for point A. So let's say we have, this is x2, y2, and this is x1, y1. You can simply go x2 minus x1, which is 4 minus -5, which is 9. So you can simply put 9 there, or y2 minus y1, which equals -1 minus -3, which is -1 plus 3, which is 2. So you can simply do that in order to find the vector joining 2 points. Okay, so let's try another one. So let's give you a point over here. 1, 2, 3, 4. 1, 2, 3, 4. So this is our point A. 1, 2, 3. 1, 2. This is point B. And I want to go from point A to point B, and let's call this vector M. And I want to know what vector M equals in both notations. Okay, so try that out, come back when you're done. Okay, so we have the 2 points here. We have point A, which is at 4 and -4 for x and y. And we have point B, which is located at -2 and 3. So that's x2, y2. So let's go x2 minus x1, because we're going from point A to B. B has to be x2, y2. So then we have -2 minus 4, which is -6. So it's -6i, because if you think about it, from point A to point B, we're moving to the left 6 units, right? 1, 2, 3, 4, 5, 6 units. Okay, and now we're going to do y2 minus y1, so that's 3 minus -4, which is 7. So if you have a look over here, we're moving up 1, 2, 3, 4, 5, 6, 7. We're going 7 units up to get to our endpoint. So therefore it's plus 7j. And if you write it in the alternative notation, it's -6, 7. Okay, so thanks for watching the tutorial on how to find the vector joining 2 points. See you guys next time.